Okay, we're going to look at logical operators. Basic logic. Logical operators deal with Boolean values, true or false, as we briefly covered before. If you recall, a bool takes on one or two values, true or false, or 1 or 0. The basic logical statements that we can make are defined using the built-in operators. These are equal sign, not equal, less than, greater than, less than or equal to, and greater than or equal to. So here, this is about checking whether 5 is equal to 5. Good, it's true. Is 5 greater than 5? False. These comparators also work in conjunction with variables. And here is really asking you, is m smaller than n? I'm sure you know the answer to that. We can string these comparators together to make more complex logical statements using the logical operators, or and also not. Let's move this up a little bit so we can see the whole thing. So you have statement 1, 10 is greater than 2. Statement 2, 4 is smaller or equal to 6. So print statement 1, true value, formatted. Okay. Again, you repeat the same format. All right, so this is really saying insert this here, insert this here. Is this true or false? Insert this here. True or false? Insert this here. Statement 1 and 2 combine n. So let's just run this. So this one is true. This one is true. Hence, you have the value 2 here, value true here, and statement 1 and 2, because they're both true, so the n basically gives you true as well. The OR operator performs a logical OR calculation. This is an inclusive OR. So if either component paired together by OR is true, the whole statement will be true. The AND statement only outputs true if all components that are ANDed together. That's cute. Are true. Otherwise, it will output false. The NOT statement simply inverts the true value of whichever statement follows it. So a true statement will be evaluated as false, and a NOT is placed in front of it, when a NOT is placed in front of it. Similarly, a false statement will become true when a NOT is in front of it. So basically inverting it, really. Say we have two logical statements or assertion, P and Q. The truth table for the basic logical operators is as follows. I think best to let you read through those. I'll pick line number 1. If both are true, not P, meaning inverted, it becomes false. P and Q, because they're both true, you get true. P or Q, because they're both true, also true. False, true, okay, when not P, meaning turning false to true. P and Q, because there is a false here, so automatically it inverts to false. But if it's an OR, meaning any one of these is true, it becomes true. All right, so I'll let you play around with the other two combinations. We can string multiple logical statements together using the logical operators. Print 2 is smaller than 3, true. And 3 is greater than 0, true. True and true gives you true. Or 5 is greater than 6, false. And not 4 is smaller than 2. Is 4 smaller than 2? False, but because it's a not, this is true. Because this is false, we have to AND because we're doing an AND. Okay, when you have a true and false and you have an AND, this becomes false. If you have a true here or a false here, hopefully the answer is a true because there's an OR here. So let's just play it. True. Okay, I strongly suggest you play around with that, work through that in your mind, because I went through that pretty quickly. But it will help you immensely by referring to the table. So logical statements can be as simple or complex as we like it, depending on what we need to express. Evaluating the above logical statements step by step, we see that we're evaluating true and true, or false and not false. This becomes true or false and true, subsequently becomes true or false, ultimately being evaluated as true. Now because we are using computers, it will calculate the calculation very quick, so it's not really a problem. But if you are a human being, the moment that you see an OR here and you have two-sided statement, you see that this is true, then you forget about the rest. Remember, anything OR true gives you true. Okay, so it doesn't matter if the second part is true or false, you will still get a true as long as this is already true. But anyway, you were using computers, so it doesn't matter. So, truthiness. Data types in Python have a fun characteristics called truthiness. What this means is that most built-in types will evaluate as either true or false when a Boolean value is needed, such as with an if statement. As a general rule, containers like strings, tuples, dictionaries, lists, and sets will return true if they contain anything at all, and false if they contain nothing. Alright, if you print Boolean, nothing, what do you think you'll get? So let's just run this. Okay, so it's false, it's got nothing. So print Boolean, it's got character, so it's completely opposite of that. It should give you a true. Now, again, print Boolean, notice it's empty. What do you think it should give you? False. Again, it contains value, true. And so on. For the other collections and containers, none also evaluate as false. The number 1 is equivalent to true, and the number 0 is equivalent to false as well in a Boolean context. Alright, we're gonna look at if statement now. So let's just scroll this up. We can create segments of code that only execute if a set of conditions is met. We use if statement in conjunction with logical statements in order to create branches in our code. An if block gets entered when the condition is considered to be true. If condition is evaluated as false, the if block will simply be skipped unless there is an else block to accompany it. Conditions are made using either logical operators or by using truthiness of values in Python. An if statement is defined with a colon and a block of indented cells. So here you have this comment. Okay, so this is basic format. So you have an if condition, colon. Okay, this is indented, then print true. Else, print false. Here it's true. Okay, now the next thing, I is equal to 4. Now if I is equal to 5, remember here it means that we're storing the value 4 into I, the variable I. So if it's 5, then print that has the value of 5. Now we know that I is not 5. So remember here it actually states quite clearly that if the condition is false, it will get skipped altogether. So when you run this, most likely you're not going to see anything at all. Because in this statement, I is equal to 4. Because in this statement, I is equal to 4, and the if statement is only looking for whether I is equal to 5, the print statement will never be executed. We can edit an else statement to create a contingency block of codes in case the condition in the if statement is not evaluated as true. So we have added this. Notice that this is unchanged. Now that if this is false, this will print. Okay, so that variables I is not equal to this will be printed, as will this, because I is equal to 4. We can implement other branches of the same if statement by using ELIF, really means else if. We can include as many else ifs as we like until we have exhausted all the logical branches of a condition. I is equal to 1. If it's equal to 1, print is 1. If it's equal to 2, equal to 3, on and on it goes. Alright, so good thing is 1. So here, we can come here and change it to 4. I should get, I don't care. Yeah, there you go. So let me change it back. Alright, let's scroll this up. We can also nest if statement within if statement to check for other conditions. Alright, in this case, I is equal to 10. If this, basically I modulo 2, remember 10 is divisible by 2, so you will get a no remainder, which is 0. Then this statement is true, then we will start looking at this branch here. Right, can it be divisible by 3? The answer is no, so this gets skipped. Is it divisible by 5? If it is yes, then I is divisible by 2 and 5. Wow. Right, okay, so let's print this. There we go. If we change it to 13, what does it get? There you go, you get this. So really, that's really the basic idea of playing around with these until you understand how the conditions work. Again, you can't break it, so just play around with it. That's really the best way to get the hang of this. Now remember that we can group multiple conditions together by using the logical operators. I is equal to 5, j is equal to 12. Is I less than 10? True or false? True. And j is greater than 11, true or false? True. So if they're both true, this gets printed. You can use the logical comparators to compare strings. My string is this. If my string is equal to this thing, then print for the glory of Rome. So let's just print this and see if it's for the glory of Rome. Okay, it's exactly the same. Let me just try if we add an R here. Voila, it's not. Okay, I think you will get the gist of it. Really, programming a lot of time is about playing around until you get the hang of it. And it's really, you can't break it. Okay, as with other data types, equal would check for whether the two things on either side of it have the same value. In this case, we compare whether the value of the strings are the same. Using greater or smaller or any of the other comparators is not quite so intuitive. However, if we stay from using comparators with string in this lecture, comparators will examine the lexicographical order of the string, which might be a bit more in-depth than you might like. Some built-in functions return a Boolean value, so they can be used as conditions in an if statement. User-defined function can also be constructed so that they return a Boolean value. This will be covered later in function definition. The in keyword is generally used to check membership of a value within another value. We can check membership in the context of an if statement and use it to output a truth value. So if this is my string or E is my string, these are my favorite vowels. Okay, so A and E are definitely in my string. Here we use the in to check whether the variable my string contains any particular letters. We will later use in to iterate through list.